Hi there, everyone. It's Mrs. Ortiz, and we are working on Objective 4, which is quadratic equations and expressions. And so the two things that we do to quadratic equations are we solve them using a number of different tools, and we factor them, and that is really the inverse of distribution. So right there, we're going to get into that. Remember that factoring is the inverse operation of distribution. You can think of factoring as undistributing. And before we practice factoring, let's show distribution in 3 different ways. So there are a number of different factoring techniques that you can use. And you can guess and check. You can use grouping with the diamond, which is also the AC method. You can use an area model, which still requires the diamond and the AC method. But both of those are at least strategies that don't just leave you guessing and checking. But to understand factoring, we need to understand what distributing is. So first we're going to distribute using the FOIL method, and it would make my heart so happy if you didn't even know what I was talking about when I say the FOIL method. So the FOIL method really is, you probably maybe have seen it but don't know that it's called the FOIL method. It's just double distribution, but it's you multiply the first terms and the outer terms, the inner terms, and the last terms. The problem with the FOIL method is that it only works when you have 2 binomials, okay? So if you're multiplying a binomial by a trinomial or you have monomials involved, then FOIL does not work. All right, but what we do is we do m times 3m, and so that's 3m squared, and m times 7, which is 7m, and then we're going to do negative 6 times 3m, which is negative 18m, and then we're going to do our last terms, negative 6 times 7, which is negative 42. And then we're going to combine like terms, and we get 3m squared minus 11m minus 42. So that's using the FOIL method. Okay, the second method we're asked for, and I'm going to need some space, I'm going to erase some stuff here, is using double distribution. Okay, so did you hear my kids? Did you hear my son honking in the background? All right, so for double distribution, it means that really what double distribution means is that we're distributing m to this binomial 3m plus 7. And then we're also distributing negative 6 to that binomial. So we can write it like this. So that's double distribution form. So we're going to distribute an m. M times 3m is 3m squared. M times 7 is 7m. Distribute a negative 6. We get negative 18m. And negative 6 times 7 is negative 42. And then we're going to combine like terms. So it's negative 11m. And we get the same trinomial, 3m squared minus 11m minus 42. Okay? And then the last, again, I'm going to erase so that I have some space, but the last strategy that we use is distributing with an area model. So with an area model, we're going to let the binomial m and negative 6, so it's got 2 terms, so we're going to have 2 columns. And then we're going to multiply by this other binomial that has the terms 3m and 7. And since there's 2 terms there, it's got 2 rows. And then we're going to find the product for each cell. So for this cell right here, we're going to multiply 3m times m. So that is 3m squared. And for this cell, we're going to multiply 7 times n, which is 7m. For this cell, we're going to do negative 6 times 3m, which is negative 18m. And for our last cell, we're going to do negative 6 times 7, which is negative 42. And then we need to combine like terms and write this as a trinomial. Okay, so the reason I wanted to do this is because I want you to really, really think about factoring as working backwards to distribute, okay? And the whole reason that we factor is so that we can solve quadratics. So I'm going to use two strategies, the area model and grouping, and really both of them are grouping. They're just the way you set them up is differently. So I wanted to review the distribution so that the strategies make sense. Okay, so we're gonna okay, sorry, lost a headphone. So we're gonna jump in and we're gonna factor this expression number 15, p squared minus 18p minus 19. And for all factoring problems, I use a diamond, and I use what is called the AC method. And the top of the diamond are is the product of a times c. And remember, when I say a and c, I'm talking about the coefficients for the standard form of a quadratic expression. So a is the coefficient of x squared and c is the constant, okay? And then b is the coefficient of the linear term, just x, all right? And then down here is b, all right? And then what we're going to do is we're going to look for two numbers that go in these sides of the diamond that multiply to equal AC and add to equal B. So if we set up our diamond for this, we know that A is equal to 1, B is equal to negative 18, and C is equal to negative 19. And A times C is negative 19, and B is negative 18. So we're looking for two numbers that multiply to negative 19 and add to a negative 18. So the only two factors of 19 are 1 and 19. We need to multiply them so that they're negative. So one of those numbers has to be negative, and they need to add to be a negative 18. So we want the 19 to be negative, and so that they have a product of negative 19 and a sum of negative 18. Now, if you are really familiar with factoring, you feel really good about it, you might remember this. If a is equal to 1, you don't really have to do much more work. As long as you know that a is equal to 1, you can just use these two factors and go ahead and factor your problem. So we get p plus 1 times p minus 19. And that's it. It's factored. Okay? Now, if you're not as comfortable with that, if you're very methodical and you want to make sure that you don't make mistakes, although it will take more time, okay, you can factor by grouping. So I'll do this one by grouping. So what we're going to do is we're going to take these three terms and we're going to split them so that it becomes 4. And so we're going to split the middle term using these two numbers. So we start with our p squared, and then this becomes minus 1p and minus 19p, and then we keep our 19 at the end for c. Okay, so sorry, that's supposed to be a positive p, and you need to check. That's how I caught it, because I know that 1p minus 19p has to be equal to negative 18p. Okay, and then we're going to group. So we group the first two terms and we look for a GCF. The GCF of p squared and p is p. And we're going to group here and we're going to look for a GCF. The GCF of negative 19p and negative 19 is negative 19. In the first grouping, we're going to factor out a p. And then we need to figure out p times what is equal to p squared. So p times what is equal to p squared, and that's p. Plus p times what is equal to 1p, and that's a 1. Then we're going to factor out negative 19 here, and we know that negative 19 times p is negative 19p, so we're finding that for that term. And negative 19 times a positive 1 is a negative 19, so we're finding that term. And then we will rewrite this as the repeated term, p plus 1, times the coefficients of that term, p minus 19. because remember that this is double distribution, so we can rewrite it in this form. Okay, so let's take a look at number 16. So we're going to factor, let's see here, 8n squared plus 47n minus 35. So the first thing that we need to do before we can factor this, sorry, it says to solve by factoring. So it has to be an equation if we are solving. So we're always looking for an equal sign in an equation. But the first thing we have to do is set this equal to 0 in order to solve a quadratic. So we're going to add 35 to both sides. And we've got 8n squared plus 47n plus 35, and that's all going to be set equal to 0. Okay, for this one, I will use the area model. So I'm going to go ahead and make my diamond. A times C is 8 times 35. I might bring my calculator out. So here you go. You get to see. So 8 times 30. Well, 8 times 3 is 240. And then I need to do 8 times 5, which is another 40. So hopefully that's 280, because if it's not, then I'm going to do this all wrong, and that will be bad. Plus 35 in the denominator. So now we are looking for two numbers that multiply to 280 and add to 35. So both of them are positive. And you're going to just start kind of messing around here. So 280 could be 28 times 10. And but then you check, does that add up to 35? And it adds up to 38. So that's too much, but you know it's got to be somewhere in this range right here. So it's time for me to get a calculator, and I'll be right back. Okay, I got my calculator, and in the meantime, I noticed that I put not B in there, so that's not helpful when I make that mistake. So we need 47 down here. So again, this 28 times 10 multiplies to 280, and adds up to 38. So that's not, we need a little bit more separation, and to get them to add up to 47. So think about 28 and factors of 28. 7 goes into 28. So if we do 280 divided by 7, we get 40 because, and 7 times 4 is 28, right? So, and 40 and 7 add up to 47. So there are our factors. Okay, now I told you I was going to set this one up as an area model. So I'm going to move that down. And because we are starting with the simplified form, it goes in the boxes, and then we're working backward to our factored form to find those two binomials. So in the first box is the first term, and the last box is the last term. And in the two boxes that are left, the diagonal ones, we are putting in the 40 and the 7n's. So 40n and 7n. And then from here, we just need to look for GCFs in each row. So I'm going to look up this row, and I'm going to look for a GCF between 8n squared and 7n. That's an n. And then if I'm trying to find this cell, I know that it has to be n times something equals 8n squared. And that's going to give me this spot. So that's got to be 8n. So 8n times n is 8n squared. If I'm looking at this cell, I know it's 8n times something equals 40n. Well, that something has to be 5. And then if I look at this cell, 5 times what equals 35, that's got to be 7. And now I can check this cell. Is 7 times n equal to 7n? And it is. So that's our factored form. We know that it's n plus 5 times 8n plus 7. And there you have it. It's done. Okay, no, it's not done because we were supposed to solve, so we're going to continue. Oh my goodness, I feel like my brain is mush. Okay, so we're going to set each of these factors equal to 0. N plus 5 is equal to 0, and 8n plus 7 is equal to 0. And this is called a zero product property. Okay, we're going to subtract 5 to solve for n. we get n is equal to negative 5, and we're going to subtract 7. We get 8n is equal to negative 7, divide by 8, and n is equal to negative 7/8. And those are our two solutions for number 16. Okay, so for number 17, we're asked to solve this quadratic by using the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so we already talked about standard forms. We need to set this equation equal to 0. So we're going to subtract 11a. We get 4a squared minus 11a minus 108 equals 0. And we're going to identify a to be 4, b to be negative 11, and c to be negative 108. And we'll go ahead, see if I can find some space, and we're going to substitute in. So x equals the opposite of b, that would be a positive 11, plus or minus the square root of b squared, so we're going to put that negative 11 in parentheses and square it, minus 4 times a, which is 4, times c, which is negative 108, all over 2 times a, which is 4. And then we're going to use order of operations and simplify. So we've got 11 plus or minus the square root of negative 11 20 squared is 121. And then 4 times 4 times, so negative 4 times negative 108 is 1728. All over 2 times 4, which is 8. And 1728 plus 121 is 1849. So we've got x equals 11 plus or minus 1849 over 8. And then we've got to simplify. We're going to take the square root of this 1849, and that's 43. That was nice of that number to be a perfect square. And we're going to do, now we need to split this because we've got this plus or minus. So now we're going to do 11 plus 43 divided by 8, which is 6.75. That is exact, or you can do 6 3/4. Either one is exact, okay? Doesn't matter if it's a fraction or decimal. Or x could be, now we're going to do 11 minus 43. Divide that by 8, we get negative 4. There we have it, using the quadratic formula. Okay. All right, in number 18, it says the quadratic equation 2x squared plus 21x equals negative 40 has been solved. Justify each step. So the first thing that was done was we added 40, right? So we set the equation equal to 0 by adding 40. All right. And then we're to go from step 1 to step 2, okay? We are changing this trinomial into a 4-term polynomial by splitting the middle term. So we split 21x to 16x and 5x. Okay, so then it looks like when this was done, the first 2 terms were grouped and factored, and the second 2 terms were grouped and factored. So we're going to say group terms and factor. And then we're going to rewrite, so to go from 3 to 4, we factored out a 2x and a 5 from this term x plus 8. Okay, so we're rewriting this as double distribution. So we factor out 2x and 5 from x plus 8. Okay, and now we're going to solve it. So we're going to set up the zero product property. So set each binomial, so the 2x plus 5 is a binomial and the x plus 8 is a binomial, so set each binomial equal to 0, and that's using the zero product property. Okay, and then we're going to solve each equation. So solve for x in each equation, and that would be a description of a step-by-step solving for a quadratic equation using grouping. Okay. So in number 19, it says, write an example of a quadratic that can be solved by factoring, and then write one that must be solved by the quadratic formula, meaning that it cannot be solved by factoring. So you might, I hope the wind is not making this hard to hear. So if you want to work backwards, if you're doing this, write one in factored form. It doesn't matter what it is. X plus 7 times x minus 2, and then go ahead and distribute that out. X times x is x squared. X times -2, 7x, and then, let's see here, -14. So we've got x squared plus 5x minus 14, right? And then if you want to do one that's not going to factor, that you would have to use the quadratic, you could even use the same one and like maybe change this so that it's not a factor of -14. So maybe we could change it to x squared plus, let's try 6x minus 14. And so let's see, can we make the diamond? If it's not going to factor, then we should not be able to make the diamond. So a times c would be -14, b is 6. So we're looking for two numbers that would multiply to -14. So our choices are 1 and 14, 2 and 7, that add to 6. And so you're never going to be able to fill this, so then that works. Okay, it cannot be factored. Okay, at this point, I am at the pretest, so if you want to see how I do these problems, you can keep chugging along. Otherwise, you can stop here and work on your homework. So for number 7, we are asked to factor k squared minus 6k minus 27. I know that a is equal to 1, so I can use the diamond. A times c is 1 times -27 is -27. And we need two numbers, and b is -6. So we're looking for two numbers that multiply to -27 and add to -6, so -9 and 3. And because a was equal to 1, we can jump to just using these two numbers for our binomial. So k minus 9 times k plus 3. And number 8, it asks us to factor completely. So this is actually a difference of squares. So you would want to identify it as a difference of squares. You can still do the diamond, okay? So you can still do 25 times -16, and then b is equal to 0. Now, if you remember how to factor a difference of squares, you might just remember that it's the square root of each of these. And so square root of 25n squared is 5n, and the square root of 16 is 4. And it's the sum and the difference of those same binomials. So 5n plus 4 times 5n minus 4. And then it asks us to factor completely, so we need to look at each factor. 5n plus 4 cannot be factored, and either can 5n minus 4. And so that problem is done. Okay, and then we'll take a look at number 9 here asks us to solve this one by factoring. So 5v squared minus 21v plus 4. When we set that equal to 0, and we'll set up our diamond. 5 times 4 is 20, and b is negative 21. So we're looking for two numbers that multiply to be positive 20 and add to be a negative 21. So that would be a negative 20 and negative 1. And so I'm going to do this one by grouping. So I'm going to split my middle term. So I start with my 5v squared, split negative 21v to negative 20v minus v plus 4 equals 0. I'm going to group, take out a 5v. I'm going to group, take out a negative 1. I'm going to take out 5v. I'm left with v minus 4 for the factor. When I take out a negative 1, I'm left with v minus 4 again. I've got this common factor here, so I can factor out a v minus 4 from each of those, and I'm left with 5v minus 1, and that's equals 0. I needed to solve this, so I'm going to set each equation equals 0, v minus 4 equals 0, so v is equal to 4, and 5v minus 1 equals 0, so I'm going to add 1, 5v equals 1, divide by 5, and v is equal to 1/5. And so our two solutions, our solution set is a positive 4 and a positive 1/5. And that's it. All right, have a great day. Bye.